Welcome everybody to our Calculus AB, BC videos. I'm Coach Meidenbauer. We're going to go over applications of implicit differentiability. A couple of things I do want you to know here, that when we do get dy dx in its final form, we have a horizontal tangent. If we have a 0 on top and the bottom is not 0, we have a horizontal tangent. That should be not new to us, right? If the derivative is equal to 0, we have a horizontal tangent. We'll have a vertical tangent if we get a 0 in the denominator. That means we're undefined and we have values on top. The curve will cross itself if the derivative is in the form of 0 over 0. So if the derivative has a quote-unquote hole, it doesn't really have a hole. It just means that the curve crossed itself. Okay? So what we're going to do here is we're going to go to L is the curve of y squared equals x squared minus 3x plus 2. And we're going to find the horizontal tangent and vertical tangent. Before I can find these tangents, I have to find the derivative. So what is the derivative of this? I'll do the work down here. So what's the derivative of y squared? dy, good job tagging it. dy over dx equals 3x squared minus 3. Okay? So let's go ahead and solve for dy dx. I'm going to divide both sides by 2y. So dy over dx is equal to 3x squared minus 3 all over 2y. Find the horizontal tangent. I need to make sure that the top is equal to 0. So I'm going to set 3x squared minus 3 equal to 0. This is for, I'm going to put an HT here, stands for horizontal tangent. Also, 2y cannot equal 0, so we just need to check it. Okay, so for the 3x squared minus 3, I can just divide everything by 3, right? That's going to give me x squared minus 1 is equal to 0, which will give me x equals plus and minus 1. So the numerator will equal 0 for the for dy dx if I have x equal positive 1 or negative 1. It wants the coordinate points, which means I need to find the y values. So I'm going to plug this back in to find the y values. Where do I plug it back into? All the way up here. Okay? So if I plug in an x equals 1 into that top equation, I'm going to get y squared equals 1 cubed minus 3 times 1 plus 2. If you do that math, what does y squared equal? It's 0? So y equals 0. Is that okay? Why is it not okay? Because 2y can equal 0, so that means that if I multiply this by 2 on this side, that means we get 2y equals 0. So we're going to reject this. So we're rejecting x equals 1. What if I'll go a different color here. What if I try slightly different color? X equals negative 1. Y squared equals negative 1 cubed minus 3 times negative 1 plus 2. So y squared would equal, what do we get? 4. So y equals plus and minus 2. Are those y values okay? Yeah, because they don't equal 0. So I have two coordinate points. The coordinate point of, so again, we rejected 1, but negative 1 is going to work with a negative 2. And a negative 1 with a positive 2 is going to work. Those are both coordinate points that work out. If we want to do a real quick cheat, I actually gave you this graph right here. This is actually the curve L right here. Anybody notice that ahead of time? I didn't sneak any of you? Okay. So you can tell right here we have a horizontal tangent there, horizontal tangent here, and at 1 we do cross. All right, vertical tangent. Since I have my, I'm going to kind of just shield this work off over here. Okay, I have my dy dx. So for a vertical tangent, I now need 2y to equal 0. And I need to make sure that 3x squared minus 3 does not equal 0. Okay? So it goes to say this. So it's for the, this is for vertical tangent, by the way. So if y is equal to 0, what do I do to solve for this? Plug it back in. So I'm going to go 0 squared, which was just 0, equals x cubed minus 3x plus 2. Does that factor? Or do we have no clue how to do this? Oh, by the way, that does factor. We're gonna do some old school math here. Advanced pre-calc kids would be better at this than you AP kids. Not your fault. It was a better course back then. But we do know one of these factors already because we did this problem over here. What's one of these factors we already know? We knew that y equaled 0 and x was equal to 1. So we know we can take out an x minus 1 factor, which means that in order to solve for this, let's do a little bit of long division. In doing this long division here, if I do x squared, that's going to give me x cubed minus x squared, and then we subtract that. And that gives me a positive x squared minus 3x plus 2. When I do that subtraction, I'm going through this fast because you're supposed to learn this at some point in your life. For those of you that were in advanced pre-calculus, that old class that no longer exists, synthetic division would be a lot quicker. But we didn't do synthetic division in AP pre-calc, so I'm not worried about it. Okay, x goes into x squared how many times? Very good class, x times. Multiply that through, subtract. You're going to get negative 2x plus 2, and then minus 2 times, it's going to be negative 2x plus 2, subtract that, we have no remainder, which is what we should have had in the first place. Okay, so this purple right here factors as we can take out an x minus 1. That's what long division does, by the way. And we're left with x squared plus x minus 2. Okay, getting to the weeds a bit here with algebra stuff. But does this factor a little bit more easily now? Yeah, so how does this trinomial over here factor? Copy down the x minus 1. How does this factor? I'm hearing it x and x plus 2 minus 1. So this is x minus 1 squared, x plus 2. So to solve for this, I'm going to get x equals 1 and x equals negative 2. If you remember correctly, I do reject x equals 1. I rejected it already over here. I'm going to reject it again. Anybody here ever reject the same person twice? It was fun, wasn't it? We're having that much fun right now. For those of you not laughing, lighten up. Or figure out what the joke was. Come on, people. So what is the coordinate point of my vertical tangent here? I have an x, I have the y value, I have the x value, so this coordinate point is going to be negative 2 comma 0, which is clearly right here in purple. Okay. So I'll label this a little better. So we have, for over here, we have horizontal tangent. At these points right there, and this is my only vertical tangent. This long division, that scare anybody? No one's admitting it? Okay. Alright, so we're all pros at this. Alright, flip it on over. Okay, so this right here is a modified version of, it says in the bottom corner there, of a FRQ from this past year. Guess who graded it? I did. I wasted 3.5 days of my life looking at the same problem over and over again, and kids kept making the same mistakes over and over again, so I kind of just rewrote, not the exact problem, but pretty similar to it. That way I can kind of go over, this is where kids messed up and whatnot. So let's go for it. Show that dy over dx is equal to x over 6 times this y squared minus 2y minus 1. I feel like there's an error in those notes because I tutored a kid and I don't think I ever went back and fixed it. So let's figure it out. I don't even know if this is true or not. So let's go ahead and go through this. Maybe I fixed it, maybe I didn't. We'll find out together. So let's go ahead and take the derivative of this up here. So when I take this derivative, I'm going to get the first term becomes 3y squared. Tag it. Second term becomes minus 6y. Tag it. Plus 3. Tag it. Minus 1/2 x. I'm going to add the 1/2 x to the other side. Can I take out the GCF at the same time? Is that going to offend anybody? If I can do this at the same time. So like dy over dx, 3y squared minus 6y plus 3 equals 1 over 2x. I'll put the, 1/2 x. Is that okay? Okay. And then let's go ahead and, I feel like there should be a plus 1 right here. I feel like that's where I made my error. I feel like that should be a plus 1. Just by looking at this, I can already tell. Then go ahead and divide this over. So dy over dx is equal to, the x is on top, right? X all over 2, 3y squared minus 6y plus 3. By the way, there's a typo in the notes. Can we make this into a plus 1? It's supposed to be a plus 1 the entire time. Gosh darn it, I didn't fix these notes. And I sent them to Lerman like this. We'll find out. Should have been a plus 1 the whole time. Okay, this doesn't look like that. It almost does. What's the only thing I have to do now? Take out a GCF of 3 on the bottom. So it's going to give me x over 6, y squared minus 2y plus 1. Boom, it's verified. Okay. When I graded this, a lot of kids were, that got it wrong. They either just had no clue what they were doing and they just wrote the final answer at the end, which is really annoying because I caught all of them. Or they would do something called integration, which you had not learned yet, but this specifically wants you to use implicit differentiation. So good job, everybody, on the first one. Part B. For x greater than 0, y greater than 0, there's a point C on the curve J, in which the line tangent to the curve at the point is vertical. Find the y-coordinate of the point C. Show the work that leads to your answer. How do we know when the tangent line is vertical? Set the bottom equal to 0, right? So we're going to go 6 parentheses y squared minus 2y plus 1 is equal to 0. We also need to make sure that the top is not equal to 0. So x cannot equal 0. And that is true because of, we already told that x is going to be bigger than 0. So do we need to worry about the top then? No, we're good. Okay. So does this factor on top at all? Does it factor? Yeah, what is it? Y minus 1, y minus 1? Yeah? So this is 6, y minus 1 squared equals 0. So at y equals 1. Did I answer the question? Totally did. Looks for the y-coordinate. Got it. Done. You good? So far, so easy? A lot of people mess this question up too. Kids these days. Last part here, when a particle moves along curve M, so they're kind of changing up our curve here, by 2xy plus e to the x minus 2y equals 5. At the instant when the particle is at the point -2, -1, dx over dt is equal to 3. Find dy over dt at that instant. Show the work that leads to your answer. So we have a brand new third variable being introduced here. What is that third variable you're noticing? T. So we're going to take the derivative of all of this, not with respect to x, but with respect to t. So we go through here. We're going to have, on this problem right here, we're going to have product rule. Okay? So what's the derivative of the first? And what I'll do is I'll have 2x be the first, be f of x, and I'll have y be g of x. So what's the derivative of the first? It's 2. Technically, I'm tagging it with a, because of respect to t, dx dt. So 2 dx dt times y plus 2x, which is the derivative of y with respect to t, dy over dt. Plus, what rule is going on in here? Chain rule. So it's e to the x, which the derivative of the outside is just going to be e to the x minus 2y. Parentheses, derivative of the inside, what's the derivative of x? I agree it's 1, but we got to tag it because we're doing it with respect to t, so it's going to be, oh boy, dx over dt minus, what's the derivative of 2y? 2 dy over dt equals 0. This is different than other implicit because I am doing this with respect to time. Okay? That's why I'm spitting out dx's, or instead of spitting out over dx's, I'm spitting out over dt's. I have everything. I'm ready to substitute everything in. So I'm going to replace every single x with a -2. I think that's all it for those x's. For every single y, I'm going to replace that with a -1. And then for every single dx dt, I'm replacing that with a 3. And then I'll go ahead and solve for dy dt. Sound good? All right, so this first term becomes 2 times 3 times -1 plus 2 times -2. I'll still have a dy dt. I'll solve for that momentarily. Plus e to the -2 minus -2 times -1, which is +2. Okay, which is nice because what does that turn into? So it's e to the 0, so that's nice. It'll turn into a 1 for us. 3 minus 2 dy over dt. I'm going to squeeze everything over here. This first term becomes -6. Second term becomes -4 dy over dt. This turns into a 1, so it's plus 3 minus 2 dy dt. And that all is equal to 0. Sorry, I'm squeezing it on here. What's -6 plus 3? -3, can we add to the other side? So we're going to get 3 on this side, and then how many dy dt's? I have -6 dy dt's. Is this arithmetic correct? Can someone verify this for me? Is this correct? Yes? Okay. So what does dy dt equal? -1/2? Sorry, I kind of squeezed it in there, but it's my first time ever doing these notes. You know, I tutor kids. I know these notes with that. But for the most part, that's it. Sorry, this is a long video. I apologize, people, for a long video. Hey, tell you what, if you like and subscribe, and maybe comment below, maybe I'll make the next video shorter. They're probably gone by now. I should have did this in the middle of the video. All right.